Yeah, so this is problem one. Yeah, so Bessie is looking for a new job, and then there's K farmers that are conducting interviews. Um, yeah, and we have like K is at most N, which is at most 3 times 10 to the 5. Um, yeah, and then the time starts at 0. So for the first K farmers, you're gonna have something like uh okay, yeah. So like the first K cows, um, they're going to be interviewed by the first K farmers. So this is farmer one, and then farmer two interviews this person, this cow, and then farmer K interviews this person or this cow. And once a farmer finishes interviewing someone, then it'll be available for the next cow. So some farmers at some point will be done interviewing, um, and then the next cow will be able to pick any of the farmers that are ready. And this process kind of happens immediately, right? So there's N cows. So there's K farmers that are initially interviewing the first K cows, and there's N cows, and then there's also the N plus one cow. And yeah, and then we need to know when. So there's two things we need to know. When will the N plus one cow be interviewed? And then the second thing to answer is um, uh, which cows could interview, right? So N is up to 3 times 10 to the 5. Um, so we ideally hope for something that's O of N or O of N log N. Yeah, so let me move to OneNote. Yeah, so one thing to notice in the beginning. So uh, yeah, so yeah, and then also each cow has an interview time of TI. So you have the first K cows, so the first K cows, and then the first cow will be interviewed from time 0 to T1, and then the second cow will be interviewed from time 0 to T2, and then the Kth cow will be interviewed from time 0 to TK. And the first time an interview is finished, maybe some farmers will be able to go to some later cows, right? So basically, at the min of these TIs, some subset of the farmers will go and be able to interview some cows, right? So let's say the min of TI is equal to T, then this is going to be equal to T and then T plus TK plus 1, and then T and then T plus TK plus 2, where TI is the time to interview cow I, and then you have like, let's say four of the interviews finish at the same time. Then it's gonna be T and then T plus TK plus 4, right? So basically what this gives us is that the range of the times that a cow is interviewed is going to be the same no matter what, who this chooses as a farmer, these ranges of the interview times are going to be the same no matter what, right? So they're already predetermined, you can think. Yeah, so ranges are the same no matter what. Now, we need a way to be able to efficiently process these events. So what we can do is basically each event is when some interview gets finished. So you can have up to, and some interview gets finished at the right endpoint of some time interval, right? So there can be up to O n events, where an event is where some interview is finished and they're being assigned to future cows, right? So one way we can think of this is if I draw it in a different way. So let's say that we have I cows that have already like started interviewing, or some of them might have finished. And at some event, um, let's say these cows are being finished interviewed at time T. So At time t, let's say that some cows in some subset S are finished, right? And then they go, and then the farmers that interviewed these cows go occupy these blocks. So if there's 4 interviewers that finished here at the same time, then they're all going to occupy this block. And one way we can simulate these events is can basically have like a map from int to something like vector int, where the key is like the time, and then the value is the cows that are interviewed. Sorry, the cows that have finished being interviewed. Right? So at time t, yeah, so it's going to be a vector. So it's going to be a list of cows that have finished being interviewed. Right. So at time t, let's say these cows have been finished interview, then that gives you these kind of intervals. So t from t to t plus ti plus 1, and then from t to t plus ti plus 2, right? These are just the intervals that these cows are interviewed. And then let's say there's 4 cows, then this interval will be from t to t plus ti plus 4, right? So yeah. And then once we're processing this, then we can just push this into our map. So we could do something like for I equals j equals I plus 1 to I plus whatever this length is. Then yeah, just call this events. Then you can do like events t plus tj dot pushback j, right? So basically the events is like at some time, the farmers corresponding to this vector, the cows corresponding to this vector have been finished interviewing. And when you're processing, yeah, so basically that gives you the time that each cow will be interviewed. You can compute these intervals. You can just compute these intervals, and then you can use this to be able to find when cow n plus 1 will be interviewed, right? Because we're looking for 2 things, right? The first thing is when Bessie's interview will begin, and then the second thing, which we'll discuss in a bit, is which farmers could have interviewed Bessie, right? So we solved the first part. Basically, we just have you just simulate the events using a map. So the key is the time of the event, and then the value is the subset of cows that have finished being interviewed. And when you process an event based on the size of the subset, so if the size of the subset is 4, for example, then you know at time t, 4 more cows are going to be interviewed, right? So we were able to do the first part of the problem. And then now let's consider how we're going to do the second part of the problem. Whether farmer I could interview Bessie for the first I farmers, right? So we can think of this problem as a graph, right? So I'm going to draw the same picture again because we can try to see what happens. So ideally, we want to know which farmers could have, which of the first K farmers. So like, let's say I is the number of cows that have either started interviewing, right, at the next event. So, and then at the beginning, these first K cows had like farmer 1, farmer 2, up to farmer K. And we want to see, at the end of the day, we want to see like whether cow n plus 1 is possible to be interviewed by farmer I for each I, right? So what we can do is we can try to build a graph. So basically, if there's a path from farmer 1 to n plus 1, then that means we can interview that farmer, right? So the idea is to build a graph. Yeah, so let's see what happens again. So at a particular event, this subset of the farmers have, this subset of the cows have finished their interviews. And then these are the next cows that will be interviewed immediately, right? So uh, basically these can be matched in any permutation, right? So any permutation of these is possible. So the farmer that interviewed here could go here or here or here or here. It doesn't matter. So one way we can handle this is, so these are the 4 cows that were being interviewed, and then these are the 4 new cows. Basically, the farmer that got here should have a path to all these 4. And then the farmer that was here should have a path to all 4 of these. And the farmer that was here should have a path to all 4 of these. And then the farmer that was here should have a path to all 4 of these. So what we can do is we can draw an edge to here from each farmer or from each cow. And then we can draw an edge from to here and then to here and then to here. So basically this gives us that, like, if farmer FJ had a path to this cow, then it has a path to all these 4 cows. Yeah. Note that I didn't make the edges like this. This doing something like this will give wrong answer, because you can't say that farmer FJ has a path to this rightmost one here. So yeah, if you draw the edges like this, there might be a few other ways to draw it. Like you have an external vertex outside, and then you have draw things to that vertex and then back. But just what is here is enough. So basically a farmer that has a path to here has a path to any of these, right? So basically we can build a graph, and the total number of edges is going to be O of n. It's because when a cow is finished, the out degree is at most 1. And then for the new cows, the in degree is at most 1. So basically the total number of edges is O of n. And then what we can do, when we're finally at cow n plus 1, we want to see which of the first k farmers can reach it. You can just reverse the graph, then do DFS. Yeah, so just reverse graph, then DFS. And then at the end, what this will tell you, if you can visit the jth farmer, like the first k spots, if you can visit j, then that means farmer j can visit you. So if your DFS visits farmer j, then that means farmer j can visit you. So let me summarize this. Yeah, so we can simulate, yeah, so we can just simulate this as events. And basically the start time and end time for each thing is predetermined. Yeah, and then at each time t, there's some subset of farmers that will finish, and then they can be mapped to the next cows in any order. So how we can represent this is we can build a graph where just like this. So the cows that have just finished being interviewed, you can add edges to the first cow in the new set of cows, and then you can draw an edge between adjacent cows. And then if you want to see which farmers could possibly visit it, then you can reverse the graph and DFS. Yeah. Okay. Yeah, so that's the solution for problem 1. Just give me 1 moment. Okay. Yeah, so that's the solution for problem 1. Yeah. It gave half test cases. And maybe there's a bug. I think, yeah, yeah, I think when I tried this problem, I had some bug too, and then I fixed it later. But I think my issue was I had edges like this, And this gave me wrong answer because a farmer that can go here can't go here. Yeah. But yeah, I think there are like some subtle details in implementation you might have to deal with. Okay. Yeah, so I'll go over problem 3.